In this video, you are going to learn all about how to solve for a variable in a formula or equation. Some people know this as solving literal equations. What do we mean by this? Formulas often have more than one variable. Slope, area, interest, distance, perimeter are all formulas that have more than one variable in them, and there are more. Sometimes it's helpful to rearrange the formula to more easily solve the problem. This just isn't in math class. This is in real life. And so when we do this, we're going to solve it and use all of the same rules for solving equations that we already know. It's just going to look a little bit different. In this example, we are going to start by just solving 2x plus 3 equals 7. If I want to solve this, I'm going to subtract 3 from both sides, and that's going to cancel there. And then I'm going to divide by 2. And that's going to give me x. So 7 minus 3 over 2 gives me x. Watch what happens if instead of 2x plus 3, I have 2x plus y equals 7. If my goal is to get x by itself, I'm going to follow the exact same steps as I did here, because we're still solving the equation. But when I subtracted 3 up here, I have y down here. So we're going to subtract y from both sides. That means y is gone. I cannot combine these because they are not like terms. Then I have 2 times x, and to get rid of 2, I divide by 2. And so I'm going to divide this whole side by 2. So when I solve this equation for x, I end up getting 7 minus y all over 2. And I have now solved the literal equation with multiple variables in it. I've solved it for one variable. This is helpful for when you have formulas. So here's the formula for the circumference of a circle where we want to solve for the radius. So if you were in real life working and you knew the circumference of a bunch of circles and you wanted to know the radius, it would be helpful to rearrange this formula to get radius by itself. And then you could just plug in whatever the circumference is into your new formula and have a quicker way to solve your problem. So we're going to solve for the radius. In between all of these is a times. The opposite of times is divide. So we can divide both sides by 2 pi. That gets rid of 2 pi over here and leaves us just with radius. So it seems like radius equals the circumference divided by 2 pi. So we are using the exact same steps we would use as if these were numbers, but we are leaving them just in a different kind of equation. We're just rearranging these formulas. Algebraically, let's look at these equations. We are going to solve x equals y plus z for z. I'm going to go ahead and put z in a box so I remember that I want to get it by itself. If I look here, I've got this y that I need to get rid of, which I can do by subtracting y. X and y are not like terms, so I must leave them separate. And I now have z by itself. So I'm still doing the opposite to solve just like if they were numbers. In number 4, I'm going to solve a equals b times c minus d for b. I want to get b by itself. So I'm going to box b. If I remember when I solve equations, I add or subtract before I multiply or divide. So I'm going to add d to both sides. A plus d has to stay separate. They're not like terms. Equals b times c. I want to get b by itself. So I'm going to divide by c. I'm going to divide that whole side by c. There's no like terms to combine, so I'm just going to flip this and say b equals a plus d over c. And I'm done. When you solve these equations, always make sure you're solving for the variable that's asked, and then make sure you're following just the same rules that you know from solving regular equations.